Okay, the next few slides is um, to show more on the developments in industrial catalysis from the year of 1900 to 1900 to 20s. So I think you can read it on your own. So this slide to show you the industrial catalysis in 1950s. This is in 1970s. You can see the developments of different types of catalysts at different years, different decades. Okay, so in 2000, we can see that the types of catalysts is getting smaller and smaller. We are talking about nano, um, meso, micro. Okay, so the types of catalysts is even more advanced. Okay, I'm gonna skip this. All right. For this slide, it defines the promoters. Actually, I have defined the definition of promoters in previous slide, in which that it is a substance whereby this substance is not a catalyst, but it helps the catalyst to be more active and to be more efficient. So we call these substances as promoters, or other name is activators. So for example, in Haber process, let's say that we already have iron which acts as catalyst, but if we add a little bit of molybdenum, it actually will increase the activity of iron in Haber process. Haber or Haber process. Okay, Haber process is actually a process to synthesize ammonia. Okay, another example of using promoters to help catalysts, to assist the catalyst, is in the manufacture of methyl alcohol from water and gas. For example, in the manufacture of methyl alcohol, zinc oxide is the catalyst, but with the help of chromic oxide as promoter, it will help the activity of zinc oxide to be accelerated to produce the methyl alcohol. Okay, once we have defined the promoters, of course, there will be a definition for catalyst poisons. So, catalyst poisons is actually a substance that will destroy the activity of the catalyst. And we call the process as catalytic poisoning. So, for example, catalyst poisons is the arsenious oxide, in which this arsenious oxide, when it reacts um, with gases, um, for example, in the manufacture of sulfuric acid, in the manufacturing of sulfuric acid, so this arsenious oxide is actually will reduce the activity of platinized asbestos, for example. So another example of catalyst poisons, maybe in the process of Haber process to produce ammonia. Again, we have catalysts, iron as catalyst, but the catalyst poisons maybe is the hydrogen sulfide or carbon monoxide. So the presence of this hydrogen sulfide or carbon monoxide would actually reduce the catalytic activity of this um, iron oxide in Haber process. Another example is maybe in the process of oxidation of hydrogen, where the catalyst involved is platinum, but with the presence of carbon monoxide, this carbon monoxide will poison the platinum catalyst, so it will reduce the activity of the platinum catalyst. Okay, to further explain, for example, let's say in the Haber process just now, we have catalyst iron and we have catalyst poison hydrogen sulfide. So if with the presence of hydrogen sulfide here, the sulfide from this hydrogen sulfide, the sulfur from this hydrogen sulfide would actually combine with this iron, so it will produce ferrum sulfide. So this sulfur here would actually slow down the activity of this iron in Haber process, for example. Okay, let's look at the definition of autocatalysis. Basically, autocatalysis means when there is a reaction and it produces a product, and one of the products is actually can act as catalyst to catalyze that reactions. So for example, the hydrolysis of an ester, here for example we have ester, or other name is ethyl methyl ketone, and this is water, and the products would be the acetic acid here, and also this one is ethanol. And this acetic acid actually uh, act as a catalyst to accelerate the reactions to be happen faster, and the productivity may be high, for example. So we call this as autocatalysis.